Okay, here we go. Again, this is Chapter 1, Section 2, Variables, Expressions, and Equations. And what we're going to do in today's lesson is we're going to get more into the algebra part. Talking about variables, talking about expressions. We're starting algebra. Anytime you hear the word variable, you know you're talking algebra. Starting out with a problem. It says, suppose that a bike shop rents out bikes. They charge an $8 fee plus $3 per hour to rent a bike. Create a chart that tells how much it will cost to rent the bike for different amounts of time. Again, $8 fee. So if you walk into the bike shop, you've got to automatically pay $8 plus $3 per hour. So can somebody explain to me, I don't have my list of names up here, but can somebody explain to me, it says show of hands, how could I find out if I wanted to rent the bike for 1 hour, 2 hours, 3 hours? How would you go about finding how much it would cost? Okay, Dakota? That's right. Okay, why would we do 8 plus 6? That's right. So what we're doing, we're taking the 8 plus. He said both times 8 plus, 8 plus. So what we're going to do is we're going to do $8 plus 1 hour would be $3 because 1 times 3, 3. 2 hours would be an extra $6, 2 times 3. We're actually multiplying there is what I was trying to get out of him. So we're doing the $8 plus, and the process here is extremely important. For this next part, whenever we get down to the next section, here the process that you're going to actually use to find the amounts is extremely important, not just the actual answer. So let's finish this chart. Let me pull up my pen. So here we go. They charge $8 per hour plus $3, or excuse me, $8 fee plus $3 an hour to rent the bike. So for 0 hours, that's kind of odd. But what I'm saying there, if you don't even get the bike, okay, if you don't even get on the bike, as soon as you walk into that shop and say, okay, I want to rent this bike, how much is it costing you? $8. That's your initial fee. He's already told us if we rented the bike for 1 hour, it costed us $11. Rented the bike for 2 hours, it costed us, careful, $14. And the way that we did that, we did here 8 plus 3 times 1. Here we're doing 8 plus 3 times 2. For 3 hours, we're going to do 8 plus 3 hours at $3 an hour would be 17. And it's an initial. You're not paying the $8. Okay, I see exactly what you're asking. It's saying, okay, forget about the other 0, 1, 2, 3. I'm just saying, what if you rent it just for 4 hours? Okay, if you rent it for 4 hours, you got to pay the initial fee plus $3 for each of those 4 hours. And if you pay, I'm not counting it each time. I mean, it looks like I'm adding an extra $8, but it's the same $8 that I'm putting in there each time. That's a good question. For 4 hours, it was 8 plus 3 times 4. That's 8 plus 12, which is $20. So does that make sense, the process that we go about finding how much we're renting or how much we're paying per hour or how much we're paying for this bike? Let's talk about variables now. In the previous problem, do we know how many hours we're going to rent that bike? No. It says here, variables are letters that take the place of unknown quantities in mathematical statements. Instead of saying 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, if we're unsure how many hours we're going to rent it, we can say it's X hours, Y hours, Z hours, H hours, A hours, B hours, C hours. We can use placeholders and just say we're going to. And you might have heard the expression. Somebody might say, I'm gonna use the car for X number of hours. You know, I'm not sure how many hours I'm going to use it for. I'm going to use it for an X number of hours. But again, it says variables are letters that take the place of unknown quantities in mathematical statements. Since we are not sure how many hours that a customer is renting a bike, we can use a variable to take the place of this unknown quantity. The cost of renting the bike is $8 plus $3 for each hour. This can be written as, very important that you know where that came from, 8 plus 3h. This is called an algebraic expression. Go back to the process of finding how much we're paying for each hour, or how much we're paying for each each amount of hours. We always did $8 plus $3 times however many hours that is. So evaluating this expression, plugging into this expression can show us however much it's going to cost. What if we wanted to rent it for 20 hours or 30 hours or 40 hours? We could use that same expression. Again, that's called an algebraic expression. There's your vocabulary word that'll pop up from time to time. We can now use this expression to find the cost for renting the bike for any amount of time. When plugging different values into an expression, the process is called evaluating the expression. Example 1. It says evaluate the expression 8 plus 3h to find out how much it would cost to rent the bike for 6, 8, and 12 hours. 8 plus 3h, what did I say, 6, 8, and 12 hours? Okay, hang on a second. Let's go through the process. I want you to keep in mind, all we're doing here is plugging in. It's the same thing. We're evaluating just like we did on the previous problem. Also, just in case somebody might not know, 3h, when you have a number and a variable next to each other, that's multiplication. That's the same thing as putting a dot in between it, like this. 3 times h is the same thing. If it's a number and a variable, you can just put 3h. So we're evaluating this expression. I want to know how much is it going to cost for 6 hours, 8 hours, 12 hours. For 6 hours, all you have to do, and again, this is called evaluating an expression. We're simply plugging in 6 where there's an h. Take out the h, put a 6 there. So 8 plus 3 times 6. And also you can use parentheses like that to indicate multiplication. It's the same thing as saying, what if I rented the bike for 6 hours, how much it would cost? That's 8 plus, the 3 times 6 is 18, which was, like Dakota said, it's going to cost us $26. Any questions on how to do that? For 8 hours, we would do 8 plus, we're evaluating the expression, we're plugging in 8 for h. That's going to be 8 plus, what is 3 times 8? 24, so 8 and 24 is 32. And finally, for 12 hours, we'd do 8 plus 3 times 12. And notice again, all I'm doing is where there's an h up here, I'm putting these different values. That's evaluating the expression. 8 plus 36, and that would give us $44. We can use that same expression. It doesn't ask us to do this. But what if for some reason I wanted to rent that thing for 100 hours? And I wanted to know. $308. Easy. It's that simple. Instead of hours, because again, that's a placeholder. We don't know how many hours. It could be 6 hours, 8 hours, 12 hours, 100 hours. Just if we want to know how much it was going to cost us for 100, you put 100 there. 3 times 100, like he said, is 300, plus the 8 is $308 to rent it for 100 hours. Back to the notes. It says an equation is a mathematical statement that says that two things are equal. Notice that the root word of equation is equate. You need an equal sign for equations. We're going to talk a lot about equations this year. This is just kind of introducing it. And we're about to show you the hardest way to solve equations. We're going to show you the hard way first by, this is kind of plugging in, and then later on we're going to talk about the easier ways. Example 2 says the bike shop also rents out inline skates. They charge $2 per hour plus $4 upfront fee. Write an expression that represents the cost of renting the skates. Then write an equation that relates the expression to a total cost of $10. Let's take that apart at a time. First part, $2 per hour and a $4 upfront fee. You need to get really good at writing expressions. Because, again, algebra is based on what I'm about to show you. If it costs $2 per hour, okay, let's think about that. Let's stop at just $2 per hour. If you rent it for 1 hour, how much does it cost? 2 hours? $4. 10 hours, $20. 20 hours. How are you finding those values? You're taking the $2 and you're multiplying it by the number of hours. Does everybody understand that? 5 hours, 2 times 5 is $10. Okay? So it's going to cost $2 per hour. Anytime you see $2 per hour, 2h. $2 times the number of hours. Now, that's not all we've got to pay. You've also got to pay a $4 upfront fee. So how does that change our expression there? you got an extra $4. You can ride this 4 plus 2H or 2H plus 4. That's what it's going to cost to rent those inline skates. $2 per hour, plus you got to pay another $4. So think about the process again. If I said, okay, don't do the expression. If I say, what if I wanted to rent it for 10 hours? Okay, back to the lesson. Again, 2H plus 4. Let's talk about if I want to know how much it's going to cost for 20 hours. We would do $2 times 20, $40, plus we had to pay that $4 upfront fee. It cost us $44. Does everybody understand? That's the process. That's what an expression is. It's the process that you went through to find out how much it's going to cost. So now let's look at the second part. The second part says it said write an expression. We did that. Then write an equation that relates the expression to a total cost of $10. Okay, let's go back and show you what that means. 2H plus 4, that's how much it's going to cost. Makes sense. That's how much those inline skates are going to cost to rent. I want to know how many hours can I rent it for to where it's equal to $10, and the answer would be 3 there. That makes sense? What you just found is, yeah, if you just plug in numbers for the H's, okay, 1 hour is going to cost how much? $6. 2 hours is going to cost 8. 3 hours is going to cost. H equals 3 is the actual solution to that equation. That's what technically you're doing when you're solving equations. You're finding out what can I put in there for H to make it a true statement, to make it equal. Good job. And that's what it's saying there. The solution to an equation is the value that you can substitute into a variable that makes a statement true. And you did find the solution. That was example 3. It says plug values into the previous equations to find one that makes it true. You just did that. Example 4. Nearly finished. Example 4 says Jessica places 3 photos on the cover of her photo album. She places 4 photos on each of the other pages. She has 155 photos in all. How many pages will she need if she uses all of her photos? Okay, let's think about this for a second. 3 photos on the cover. Okay, think about a photo album. She uses 3 photos on the cover, and every page will hold 4. She has 1 page. How much is it going to hold? 4. 2 pages? 8. 3 pages? Do you see the relationship between this and the previous problem? Each page, per page. You see that? 4 per page. So let's go back here and let's use a different variable. Let's use P now because we don't know how many pages we're going to use. So each page holds 4. So if we use 20 pages, it holds. How do we write that? 4. Okay, let's do the 4P first. In addition to the pages, she has another 3 on the front. Every time, no matter how many pages she uses, she always has 3 on the front. So 4P, that's the number on the pages, plus 3 more, that's how many's on the front. That's how many total photos will fit in her album. Makes sense. We want to know how many pages that she needs to use. What is the value of P to where she can fit, how many photos was it? 155 photos. So that's the equation. 4P plus 3 equals 155. I'm going to show you again. This is the hardest way to solve equations, but it's called trial and error. Plugging in stuff to find out how many pages. You can use this. You can use this on any type of equation. Plug in stuff to find out, okay, what is P equal to where it makes it a true statement. Okay, if P is equal to 20, let's just make a guess. How many total pictures is that? 4 per page, 3 on the front, 83 photos. We need 155 photos to fit. So we know it's got to be more than 20 pages. 30 pages. 4 30s plus the 3 on the front, 123. We're closer. Let's go 40. 4 40s plus the 3 on the front. Too big. Let's try 37. 4 37s. Anybody know what that is right off the top of your head? Let me show you. Let me give you a trick here. Multiply. It is 148. Some of you, y'all probably already know what I'm about to tell you then. If you want to do like a single digit number times a double digit number, shortcut. When I do 4 times 37, I do it backwards from what most people do it. I do 4 times 3 first. You know how normally you'll do 4 times 7, carry your 2, and then 4 times 3. I don't do that. I do it backwards, and it's easier. I do 4 times 30. What's 4 times 30? 120. What's 4 times 3? It's 12, right? So 4 times 30 is 120. Now what's 4 times 7? 28. Take your 120 and take your 28 and add them together. What is 148? 120 and 20 is 140, and then the other 8 is 148. So we've got 148 plus the 3 would be 151. Let's think about it. Let's use our common sense real quick. How many fit on each page? 4 per page, 3 on the front. 37 held 151. Right? We need 155. 4 more. So it's obviously going to be 38. 4 times 38 plus 3 is 155. So the solution to this equation is P equals 38. Again, that's much harder than the method that we're going to use here in the next chapter about solving equations. I'll give you a second to copy that down. Okay, next example. It says Marge's class is going on a field trip to the aquarium. The class rate is $12 per child plus $25. How many students can go if the class has $335 to spend? Again, we've got to write an expression here. Let's go back to our first sentence, or second sentence. Class spends $12 per child. Again, think through it. Okay, what if 1 child? What if 2 child? What if children? What if 3 children? 4 children? 2 children? What would it cost? 24. 3 children? 36. 4 children? 48. Do you see how we're doing that? $12 times the number of children, but you've also got to pay an extra $25. Do you see the expression? If you think through it in your mind how to find the different values, then you automatically know the expression. $12 per child, so $12. What do I do with that 12? $12 times, we'll call it C this time, stands for child. You can use any letter. Plus we got to pay an additional 25. Is it 25 per child? No, if it was 25 per child, we'd have to multiply that also by C. But it's just 25 up front. That's kind of like a while ago. A lot of times I call it your upfront fee. This number out here is the upfront. Let's see. We have $335 to spend. And we want to know how much or how many children can go for $335. Trial and error. For those of you that have calculators, this will be a little bit better. The children, the money. What if 10 children go? $12 per child, 12 times 10 plus the additional 25. Grant, do you have a question? Or? Yes. That's where we're going to start. They're introduced trial and error today, and it's leading up to. It's doing it this way to show you what is a solution. What is the solution? It is much easier, a whole lot easier. 120. No, we got 12 times 10. That's 120. $145. So we know more than 10 people. No, 12C will be 12 times C. So now what did you say? What was the answer you gave? Okay, no, 12 times 10. Yeah. 20 is 300 even. Let's do that next. No. It'd be 12 times 20, that's 240. Try that again. 12 times 20 is 240, plus the additional 25 is 265. 265. Y'all see that? I can do 12. Again, you do 12 times 2. It's 24, and 12 times 20, you just stick a 0 on the end of it. It'd be 240. And then the other 25 is 265. Let's try it with 30. Y'all can do 30 in your head. What's 12 times 3? 36. So 12 times 30 is 360. Plus 25, what's 360 and 20? 380, and then the extra 5 would be 385. Not that many can go. So it's got to be smaller than that. Yeah, let's try halfway. 12 times 25. Okay, here's you another trick. I'm just full of tricks. I'll show you all sorts of tricks for multiplying all along the way. To multiply by 25. What's a common place that the number 25 pops up? Joey, raise your head up, son. Thank you. Money. Quarters. If you do 12 times 25, that's the same thing as saying 12 quarters. How many dollars is that? There's 4 per dollar. That's $3. So what's 12 times 25? 300. Okay, you see that? To multiply by 25, think about quarters. 12 times 25 is the same thing as having 12 quarters, 300 cents, $3. So 300 plus 25 is 325. Okay. 26 would be an extra $12. That's $3.37. Okay, I got a problem here, right? Normally. Okay, normally. Looking at this, our answer is somewhere between 25 and 26, correct? But think about the problem though. You cannot have half a student. And we're asking how many students can go. How many students can go? 25 students, and you're going to have some extra money there. How much extra money would you have? $10, so everybody can get a snow cone. Good deal. Here we go. One more problem. It says, in 1990, the United Nations reported a deforestation figure of around 114,364 acres. Now I'll explain what that means in a second, per day. The area of the Olympic National Park is about 922,654 acres. How long would it take to lose an area of forest equal to the area of the Olympic National Park? Deforestation means, and this is kind of sad, means 114,364 acres of forest we lose each day due to cutting down trees for different things, building, shopping malls, and all this other. So the Olympic National Park is huge, 922,654 acres. That's big. And what it's asking is about how many days would it take if we were to start clearing that out at this same rate, 114,364 acres a day. If we started clearing it out at that rate, how many days would it take to clear out this 922? Give me a guess. About how many days? About 8 or 9 days. Does that make sense? Because 115,000 to 900,000, that's about 8 or 9 of those. Maybe 7. Here we go. Let me show you how to do this. Here you go, guys. Quiet. Let me show you how to do this with a calculator. Again, we could do solve an equation, it'd be a whole lot easier. We're going to start with 922,654, and I'm going to hit enter there and show you what I can do. After 1 day, I lose minus. If you go ahead and hit minus, do you see how it does A and S? What does A and S stand for? Answer. We're going to do the answer, which when I say answer, whatever's out here to the side, in this case 922,654. I'm going to do that answer minus 114,364. After 1 day, we'd be down to 808,290. But you might be asking yourself, well, what does that benefit us? Just doing it on a calculator like this. Look what happens when I hit enter again. It gave me another number. You know what happened? It subtracted that again. And every time I hit enter, it's going to keep subtracting 114,364. So after 2 days, I'll help you in just a second. After 2 days, you're going to have this left. After 3 days, 4 days, 5 days, 6 days, 7 days, we still have some left, right? 8 days, we still have some left. After 9 days, we go negative. That means we have no forest left. Actually, if there was some extra, we killed it too. But it would take 9 days to kill or to deforest that much land.